So this video is showing the setup of an autofocus unit.
So first connect the socket through Micromanager by running those Python scripts. Open Micromanager and connect to the sockets.
It'll take a moment or two to go.
Now you want to check your image.
And here we have the live image of a test chart.
And just adjusting the focus now.
And once we're reasonably happy with the focus,
just choose a region of interest to crop.
This just lets us see it a bit better. Wastes less disk space as well.
Now I can initiate the autofocus, and first we'll take some background images, and I'm just checking the focus. So I set the noise background first with the laser off, with the autofocus laser off, and that's the image it's taken. Then I set the parameters for another background photo.
So here we're going to take one with the laser on, and we're going to go quite a distance from focus, so 100 microns, and then 100 microns the other side of focus, get the minimum intensity of each of those and use that as a background.
Next, setting the parameters for the calibration curve. So here we'll do 100 micrometer range, or 50 micrometer range, might be faster, and set the step size to be 1 micrometer range, 1 micrometer step size, and turn the calibration on like
that. So here the calibration is running through in 1 micron steps, and at each position in the Z stage it's calculating the metric for the autofocus. So it's calculating the full width half maximum of the power spectrum, and that's what's plotted in these plot here for the two different fast and slow axes in the red and the blue, and the green is showing the average intensity in the image as well.
Okay, so now we have the calibration, we can actually start using the autofocus.
So now we can define where we want to lock onto a focus and turn on the continuous focus lock.
We'll just set the exposure time to something like 100 milliseconds for our detection camera, where we're taking images of the test chart, so it's nice and clear. And then we'll just adjust the focus a little, so that we're somewhere where we get a nice sharp edge.
So now I'm going to press down on the stage with my finger, and the autofocus is going to correct, and I'm going to then lift off my finger, and the autofocus will jump back and maintain focus of the test chart. We're then going to put a weight onto the stage, and then remove it again.
After this, we want to have a look at the line profile across one of these regions on the test chart. That will give us a nice idea of the focus, which is a little bit more easily interpretable visually. So we'll move close to focus because we just defined some arbitrary position earlier. And here we're just adjusting the Z position and getting our line profile.
So I'll set a square over those top stripes and plot the line profile, and move up and down the stage to see which bit gives us, which Z's position gives us the sharpest metric for the line profile.
And we can see that by the low level of ringing artifacts in the image.
Now I define focus and turn the autofocus back on.
And we press down on the stage again and remove the finger. And then add the weight onto the stage with the autofocus running, and then remove the weight again.
And finally we'll turn off the autofocus and do the same things, and you can see focus is lost. And that's it.